Okay, got sound now. Good. Okay, we got an exam coming up end of this week. Some people might have taken it already, depending on whether you're prepared or not. But I want to give you some advice and then do some examples to show you some of the things that I need to tell you and need to have been able to tell you on this series of assignments that started on 124. Okay, we'll get to that. Now, if I'm looking over here, it's because I'm talking to a person over here. Actually, I'm not talking to a person over here because over here is my screen that I'm looking at. Small screen in this direction over here where you are, bigger screen here. But you can imagine I'm talking to somebody here. Every once in a while, I'll look at you personally. I might even look over there, but all I see over there is a messy room, so I might not look. Okay. Let's get right to this. Okay. The whole purpose of the assignment starting from the 1024 or the 124 to the 129 to the 204 assignment is to help you make the transition from myLab, and sometimes in emails I'll say WebAssign. I'm using myLab and WebAssign. They both have similar shortcomings, and I kind of don't exactly confuse them, but sometimes I'll write down the wrong word. Anyhow, transition from myLab, which does a good job. It has some well constructed questions. I really like the way the questions are constructed, but I find that students don't get the lessons from it. Okay. And I think one of the main reasons for that is you're doing everything on the computer. They're not writing out solutions to be reviewed. And that fails to prepare you sufficiently for a test where you do have to write everything out. So we have the transition from myLab to constructed tests. I don't use online tests unless they can be proctored because I never know who's taken the tests. Okay, and it's unfair to the majority who are doing things honestly to have somebody else out there taking tests or having somebody else take the test for them. That's why I require handwritten tests with full details on the solutions. There's still ways to get around the system. There's nothing we can really do if we don't proctor. And I refuse to use these online proctoring things where you're basically being surveilled by your computer. That creates just a terrible dynamic. So we test the way we test, and there's good reason for it. Okay, so on the tests, you require full details of your analysis, all your steps, your solutions, and your reasoning. I have to be able to see how you're thinking through these problems, and I require you to show me how you're thinking through these problems. Now, at this stage, since you're not totally familiar with this, I'm a little more flexible in how I interpret this than I will be on the final. Okay. But basically, I've got to see this. In other words, if you don't show me all your details and your reasoning, I'm going to be a little more lenient than I will be on the final. But I'm still going to penalize it. Okay. So most people don't know what the heck that means. So I'm going to have to show you. I'm going to show you some examples. Now, the intent of the series of assignments here is that do the 1024 assignment or the 124 assignment. See that 10 and you know what happens. The 124 assignment, which asked you to give me the introduction, and a number of people did that, but I don't think even a majority of the class. Okay, so I know that that assignment was there. And I know some people were seeing it. Okay, so you were instructed to go to the assignments page and read the assignments. And there's a code on the assignments page, and this has been explained. I didn't do this on the first day, but I realized after a while that it would be a good idea to put the assignments in tiny print, tiny font, until they were actually assigned, because If they're not assigned yet, you go to that link and you get a broken link. You get a 404 error message. Okay. So you can easily bookmark the assignments page. I expect everybody to do this and check it every day. When you see that something is in a large font for a date that you hadn't worked on yet, you want to click on that, see what the assignment is, and do it by the deadline. On written assignments, I'm a little flexible on deadlines. If you get it to me a little bit late, it's kind of okay. myLab has its deadlines. You got to live within those deadlines. And unless you got a doctor's excuse or some really good reason, I'm not going to extend those deadlines for you because you're in a 7-week accelerated course. It's a 14-week course being compressed into 7 weeks. You can't get behind. So on the written assignments, well, you're going to need to get these to me, excuse me, in order to prepare for the exam. And that exam is going to occur late this week or next or on the weekend, depending on when you decide to take it. You're going to have it available in several places. Incidentally, I can't put exams up there yet. I wanted to put them up there for Thursday, Friday, Saturday, and Sunday. And I lost my connection to the network. So I've got to email into the help desk. I'll get them up there one way or another. But if I can't get the network, I can't access the tests to put there. Okay. Anyhow, they'll be there. So you're going to need to take it, by last opportunity Sunday evening. And again, you've got all that information. Okay, so you do kind of have a deadline of getting the written information to me. And you have kind of more of a deadline. I haven't gotten much from people. Throughout the day, I've been getting an occasional email with the attachments or with the documents. And something I want to say about that. But I get an occasional email with the documents and I respond to it. Okay, but the things I haven't responded to, I'm expecting to get maybe as many as 500 documents. Okay. And I can't get them all the night before you need them. Okay. There's going to be some delays. I'm going to be working very hard this week to respond to these documents and develop a dialogue with each one of you. So get them to me. Try not to be too late and don't wait till the last minute because you're not going to get a timely response. You need a timely response. Many times I'll respond to a document and say, well, you didn't quite do this right. Now this is good, and this is a little shaky and you really ought to do this now. So you really need to, as much as possible, send me a revision. A lot of times it's very simple revision. Here are 4 points. You're supposed to put a line through them and you didn't. Send it back to me after you put the line through them. Okay. But sometimes it's a much more extensive thing. Like all you did was you gave me an answer. There's none of the solutions, steps of your solutions, or reasoning. I don't know how you got the answer. Many times your answer can be gotten by bypassing any understanding. You can get something on the web. You can use a graphing calculator. You can use some kind of an inquiry. There are all kinds of ways that you can get right answers on some problems. If I don't see your solutions and your solution steps and reasoning, I can't distinguish and you're not going to get much credit. Okay. And you have to get used to that. So if you send me a document that just has, here's the answer, which is of course what you've been trained to do in your math courses. So it's totally understandable that you would do that, but it's not going to work here. Okay. You have to give me the details. And you've been taught in at least some courses to show your work. It's really what I'm talking about. In this case, your work is your steps and your reasoning and the reasons for your steps and what you're thinking. There are only 10 problems on the exam, and you're going to have 2 hours to do it. you have plenty of time to tell me what you're doing, okay? Now, let's say I have this red chalk for a reason, and the reason is, don't send me attachments through Canvas. As a matter of fact, just avoid using Canvas email. Use my VHCC email and use your email, your VHCC email. You can find my email address in the syllabus. And if you don't know where the syllabus is, well, I'm not going to tell you what my email address is. There are other ways to find it, but the syllabus is right there in Canvas. You just click on syllabus. It takes you to a link. You click on the link and the syllabus pops up. It takes 3 seconds. So you need that. And you should have read the syllabus. You know how you're going to be graded and all that stuff you want to know. Okay. So, check the syllabus and use VHCC email, your VHCC email, right there. I sent out a little video that our distance learning coordinator, Ken Fairbanks, made about how to manage different email accounts, give you the information you need. Most people are doing this okay. But in this course, I'm only starting to get stuff from people. And I expect I'm going to probably get a lot of stuff from Canvas. I'm going to have to reply by saying, I'm sorry, don't send me this in Canvas. Reason is, in Canvas, I've got to download, then open the documents, which gives me an automatic minute or two of delay when I can't do anything except sit there and wait for the computer to download. Now multiply that by 500 documents and you've taken 8 hours out of my week, 8 hours that I need in order to give you the feedback that you're going to need, okay? Well, anyhow, there we are. Now the intent was the 1024 or the 124, got to get that 10 out of my, okay, the 124 document or the 124 assignment on the assignments page asks you to do an introduction. Then it asks you to take one problem out of your homework and show me what you did on it. Okay. And I didn't get many of those. I got introductions, but I didn't get the second part. The 129 document, 129 assignment, then asked you to do part 1 of a 2-part midterm, at least all the problems that you were in a position on that weekend to do. Now you hadn't completed the entire set of, but both chapters, or all 3 chapters that are going to be due. So I said, on this one, do the ones you know how to do. Now on this one, and I didn't receive any of these, or very few. On this one, then I said, okay, do both parts and do all the problems. That's what the assignment is. That's what you need to get me. And if you can't get them all, do it in 2 parts. Get everything done you can by tonight or at the latest tomorrow sometime to me so I can start giving you feedback so you can adapt what you're doing in your solutions and get used to the process of showing solutions and reasoning. Okay, you can do it. Your myLab has run you through the steps. Clearly, if you did well in myLab, and people are doing real well with myLab, you've learned something, but you might not know it because you can't pull it into constructing a solution. Okay, it's there. This process just pulls it out of you. Okay, so the reality of these assignments now is then that something that should have been spread out over 2 weeks or more has been compressed into get it done right away. It's not good, it's not optimal, but the assignments were there, you're urged to do them. Okay, and again, I understand that in an accelerated course like this, you're under a lot of pressure to get these assignments done. You're having 5 assignments every week and then a written assignment. And that got to be stressful. I understand that, but I hope you were counseled when you did a 7-week course to realize you got to do double duty in this course. You got to give twice as much effort for 7 weeks as you would in a regular 14-week course. Okay? Every week you have twice as much to do as you would in the 14-week course. So these are not unreasonable assignments. This is a standard web assignment. And I keep saying web assignment, it's myLab. Okay, I don't even think myLab, I think Pearson because they're the publisher. Just shortcoming of my own brain here. Okay, okay, so going to follow with example. One bit of advice before I start: to prepare yourself for the test. I mean, it's an open book test. I can't tell you you can't use whatever resources you have at hand. I can tell you that you got to show me the construction of your assignment so you don't use resources that you shouldn't be using. But it's open resources. That doesn't mean you're going to be able to find the answer to all 10 questions in a 2-hour time limit and actually show me you know what you're doing. Okay? You're going to want a reference. You're going to need to take time. At least I advise you strongly to take time to write down everything you think you're going to need for reference on the exam. Write it down. I type it out if you want to. I'm not going to check it. If you want me to check it, send it, and I will, typed or written. But write it down, and then write it down again, compressed. That causes you to see the structure of the course, get an overview, and it's just really a valuable exercise. And I keep being amazed at the things people don't know to do to prepare for an exam. Okay, like read the text, at least read the chapter summaries, maybe look at the chapter summary problems. Do this by all means. Scan the text. Gee, I didn't notice this. That would have been helpful. Okay, get the information that you need and then try to put it in one succinct document that you've organized so you know where to look for things that you might possibly forget, okay? Or you might possibly need. All right, well, I'm going to continue on and do some examples. So the first example I'm going to do is, let me switch a couple things around. You do this if you want, but that's linear algebra. That's, of course, you got to have calculus to even start, so you don't really want that, do you? Great course. It's less algebra in it than you'd think by its title. Okay, you know what? Well, I cut these things. I'd be better off doing this. I think. Now that's even worse. What's going on here? Let's see. I feel that I cut this side. That's really terrible. Get this in a minute. There, those gaps match up. Okay. It was actually a mathematical exercise of the sort that's actually in your textbook in the chapter on mathematical structures. We don't cover that, unfortunately, but used to be covered in the course before it got revised by the system in a way that I don't particularly like, but it's all right, I still like the course. Okay, now, back to this. Okay. Let's start with list all the divisors of, let's say, well, I've used this example, 105, 105. Okay. Now you can start dividing 105 by all the numbers you can think of. And you could probably give me a list of the divisors. But dividing 105 by 1, 2, 3, 4, 5, 6, till you run out of numbers. Now you get to stop at 52, because of course 53 is more than half of this, and it's not going to go into 105. But that's ridiculous, okay? And that's not a method that's part of this course. You need to use methods of this course. And the method of this course is do the prime factorization. Now, I'm not going to go through the details of doing a prime factorization. Actually, I want to put these in order, 5 times 7. Okay. But prime factorization is 3 times 5 times 7. And what you do is first few primes are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and so forth. Okay. Well, you start trying to divide 105 by 2. Well, obviously 105 is odd. 2 is not going to divide it. Divide it by 3. Well, yeah, 3 times 35 is 105. Now you got 35. Divide that by 3. Doesn't work. 3 goes into 36, doesn't go into 35. And then try dividing 35 by 5. Well, yeah, 35 is 5 times 7. And now 3, 5, and 7 are all prime, so that 3 times 5 times 7 equals 105. And this is your unique prime decomposition. You got to know it's unique. There can't be 2 different prime decompositions of the same number. Okay, so anyhow, here's your prime factorization. Okay, that's no big deal. Easy to get, easy to do. I'm not going to ask you to do prime factorization of a 48-digit number. Okay, you need a computer to prove it. You couldn't do it. It'd be humanly impossible. Unless it was just a multiple of a lot of 2s and 3s and 5s. If it has some big prime factors, you're never going to find them. It has at least 2 big prime factors. You're never going to get to them. Okay, well, that's just a digression. Okay, here's your prime factorization. Now you want all the divisors. Okay, well, now 1 is a divisor because it's a divisor of any number, any integer. Okay. Three, 5, and 7 are all divisors. Okay, well, we're doing pretty good. Actually, now we've got the 4 smallest divisors. Then 3 times 5 is a divisor. So is 3 times 7. And so is 5 times 7. And then 3 times 5 times 7 is a divisor. And those are the only possibilities, because any divisor has to be a product of these prime numbers, except of course for 1, which is always a divisor. Any divisor except 1 has to be a product of the primes that make up the number. Now, this is a systematic way to do it. I listed all the divisors that consist just of single prime numbers. Then I listed all the divisors that consist of 2 prime numbers, the products of 2 prime numbers. Then I list all the divisors that are products of 3 prime numbers, which is, of course, the number itself, and we can stop there. If you add more prime numbers in your decomposition, you'd have to maybe go to all the multiples of 4 divisors, okay? All the products of 4 divisors. Okay, well, that's prime factorization. I want to see a clear procedure based on the prime factorization. It doesn't have to be exactly this one, but I want to see this, and I want to see that you've multiplied all the primes, and you should state that I've multiplied every possible product of these prime numbers, ideally. Now, if you didn't state that last thing this time, I'd just complain a little bit, but give you credit, okay? I wouldn't take any credit for it. But I'd let you know that you should have really done this, okay? Next time, maybe it better. Okay, well, those are your divisors of 105. What about all divisors of 24? Prime factorization of 24 is 2 times 2 times 2 times 3. Okay, so your divisors, you have 1, and you have 2, and you have 3. These are single products of single divisors, but then you have 2 times 2, because every one of these counts. Okay, 2 times 2, that's 4, and clearly 4 goes into 24. Okay, and 2 times 3. Now, those are the only possibilities using just 2 of the numbers. Doesn't matter which of the 3 2s you put together here, it's going to come out the same, it's still going to be 4. Okay, so now products of 3. Okay, well, that would be, last word I said was 3, so that's what I wrote down. And I recommend you start with the smallest and work up to the biggest. So you do 2 times 2 times 2, or you can do 2 times 2 times 3. Or you can do all 4 divisors. Okay, now these 2 would give you 4 and 6, but I don't want to see 4 and 6 until I see 2 times 2 and 2 times 3. 2 times 2 times 2 is 8. 2 times 2 times 3 is 12. And then 2 times 2 times 2 times 3 is 24. Now, there are other ways this could be written out, but this is the reasoning that I would need to see on a problem of this nature. Okay, going to just pause this. Okay, I'm going to dive into a fairly complicated negation. The negation is we want to negate the statement, if it snows, it won't rain. Okay, now what kind of a statement is this? This is a conditional. The form if P, then Q, which is written like this. P equals it snows, Q equals won't rain. Now you could, of course, choose to let Q equals it rains and make it if P then not Q. I don't recommend you do that because you get an extra negation into your stuff and it can get a little confusing. It's a little bit error prone, kind of like negative signs when you're doing equations in algebra. That's not, if you can avoid it, you want to avoid it. And you can avoid this. So snows, won't rain. Okay. Then we know we're going to be doing some negations, but we're just going to do P and Q right now. We'll worry about not P and not Q if we need them. Okay, conditionals if P then Q. Now, some people will say, well, then The negation is, if it doesn't snow, it will rain, because we just negate this and negate this. Totally wrong, totally wrong. You could do a truth table for that statement, and you should if you think that's a valid way to do it. It doesn't take long to write down a truth table for simple connective, okay? So you can test it. It's not so. And you can even think through, well, there's this case where it doesn't snow and it will rain, but that isn't, that could, in that case, it could still do this. Okay, well, I'm not going to get into that, except to say that the negation is the set of all things that can happen if this doesn't happen. Okay, so negation is a set of all things that happen if this doesn't happen. So this is a set of all things that can happen if the negation doesn't happen. That's what a negation is. You want to think through that, but it's a little complicated. You know, it's a fairly sophisticated form of logical thought that, you know, I kind of advocate that people be able to do that. But right now, let's see what it takes to at least get this introduction to some logic. Okay, so we negate this. If it snows, it won't rain. There's your conditional. And those are your statements. You want to do that. You know, you always want to do that if you have a statement. Convert it to symbols so you can use the rules for the symbols. Okay, now, there's no rule for negating the conditional. The rules are that the negation of P and Q is not P or not Q, and the negation of P or Q is not P and not Q. Now, when people do the myLab, somehow it goes right over their heads in a way that it wouldn't in a classroom, although I still see the error in classroom. But it goes right over their heads in a way that it wouldn't do so frequently in a classroom situation, or in a situation where you get a lot of feedback. Well, what we're trying to do here is have you do some work that will get you a lot of feedback at the time when you really need it, right before the exam. Okay, feedback. Not related to this problem, people miss the fact that if you're negating the and, you get an or. If you're negating the or, you get an and. And that should just pop right out at you. But for some reason, it doesn't seem to do it. And we have a sign, even though you get the right answer, you do these right, get all the right answers. In my experience, people get all the right answers in this, 70% of them will get to a test and fail to use these rules correctly. Okay, so that's an example of something you want to write down. You want to write that. I can't tell you everything to write down. What you need to write down depends on what you're getting right and what you're getting wrong, what you're understanding and what you aren't. But this is one thing that almost everybody needs to write down, and maybe a little note saying, watch out for that change in the connective. Okay. Okay, well, those are rules. Those rules don't help you. This isn't an and, this isn't an or statement, this is an if-then statement. But also, if P then Q is the same as not P or Q. Now, the reason for that is, if you know the rule for this connective, and you should, this one is true, except when P is true and Q is false, because you can't get a false from a true. Okay? So the only way this can be false is if P is false and Q is true. Well, that's the case here too. Okay? I'm sorry, I said that wrong. The only way this can be false is for P to be true and Q to be false. Okay. Now, think about it. If P is true and Q is false, then not P is false and Q is still false. And you got a disjunction of two false statements, which makes it false. So this thing has identical truth value to this. Now, in all the other cases, well, the or statement, you should be familiar with the fact that the or statement is only false one way. And that's if both of these are false. So P is true, this is false. Q is false, this is false. If P is true, Q is false, this is false. So you have to translate that. So in presenting your argument, I'm just giving you the rules up here, but you can quote this argument or this rule. Okay, this is equivalent to this. So negating if P then Q is equivalent to negating not P or Q and not P or Q is equivalent to what? Well, you're negating an or statement, which is going to change it to an and statement, and it's going to then change, it's going to negate then both of the component statements, okay? So this is equivalent to the negation of not P and the conjunction with not Q. And this is equal to then P and not Q. So now our negation is it snows and it doesn't not rain. So okay, so it snows and it rains. So the negation of this is this. So this is the negation of this. Okay, there it is. Now, negation is important, and this is one of the more complicated examples. I'm going to do one more example. And let's see, this side's going to have to match up with that side. I don't know if that's the cut side or the uncut side. It's going to either be this way or this way. Let's see. I could work this out, just a little group theory. At the level that it's represented in your text. But, okay, one more negation. All of you are right. Some of you are impolite. Maybe there's a group of people and they're all right about something, but some are being jerks about it. Okay. Okay. So how do you negate that? Well, let P equals all are right, and Q some are impolite. Just abbreviate a little bit. Okay, then the statement is P and Q. Oh, see, I almost did it. Very easy to write it down. I almost wrote an and there, didn't I? Okay. Not P and Q, which is not P or not Q by De Morgan's laws. Probably ought to know the name of that too. Okay. There it is. Okay, so what's not P? Well, we don't know what not P is unless we know the rule for negating an all statement. We can't do not Q unless we know how to negate a some statement. Okay, well, this could be written out in a little more detail. You can write it out in the detail that'll be beneficial to you. The negation of all R is some aren't. And the negation of okay, negation of some are is all aren't or none are. Okay. Often you get the mistake, the negation of all are would be that none are. That doesn't negate it. Okay. It's not true that all are. Well, it's not true that all are if at least one isn't. Okay, if at least one person here isn't right, that's the opposite of saying they're all right. It's a negation of saying they're all right. Well, there we have it. So now, so not P is some aren't right. And you could also say some are wrong. Not Q's then. It's a little clumsy to say all aren't impolite, especially since in the vernacular, all and some don't necessarily mean what they mean logically. Okay. So it might be more clear to say that none are impolite. So negation is negation of the original statement is some aren't right, or none are impolite. Just crossed out part of what I wrote. That aim. Okay, there we have it. Well, you have to go through a similar process. You need to show me all these steps. You got 2 hours, 10 problems, 12 minutes a problem. It can take 5 minutes to write this out. Of course, if you don't know it and you got to do a lot of research, it might be a strain to do all the research to find out how to do this and then write it out. Well, that's all you've got to know. That's again why I advocate that you have a good reference. Okay, you don't have to click through your book or go to Google and stuff. And not a good way to work on the test. Although might well be that in 1 or 2 problems you get that desperate. Save those for last, unless you're pretty sure you're going to be able to find a way quicker. Okay, more quickly. Okay. See what else we need to do here. Okay, now looking at truth tables. There's a new board here, ignore that stuff up the top. Truth table for this compound statement. If P then not Q, and P or not Q. To set up the truth table, first we list all the possible truth values of P and Q. Now, P and Q are both statements, so they're either true or false. So if P is true, then maybe Q is true, or maybe Q is false. Those are the only possibilities that P is true. Now, if P isn't true, that's the only other thing that could possibly happen other than P being true, then P is false. If P is false, well, Q might be true, Q might be false, and now we've got to figure out what to do with all this. So, first thing we want to do is we want to make a column for not Q, because not Q appears up here. And of course, that's just going to reverse the truth values of Q. I think everybody's good with that. And then, what do we need? Well, we're going to need this statement, and we can evaluate if P then not Q just by looking back at the truth value for P and the truth value for not Q. The rule is this is going to be true unless this is true and this is false. Very simple. Of course, we have to know that rule. So we're going to have a column for if P then not Q. And we might as well go ahead and evaluate that. Okay, it's true unless P is true and not Q is false. Well, right away we see that in the first row, P is true and not Q is false. So that in this case, if P then Q, then not Q is false. In every other case, either Q is true or P is false. So that it can't be in either of those cases that P is true and Q is false. So in all these cases, we get true. Now, to document this, you might write the rule, true unless P is true, not Q is false. There's the rule we used. Okay, and then we have P or not Q. Well, the or statement is true unless both P and not Q are false. So we could say true unless P not Q, both false. Okay, well, we look back at P and not Q, and we see that, well, P is true both here and here. So these are not both false since P is true, so we know that this statement's going to be true here and here. And then in this line, well, looks like P is false and Q is false. So in this case, the disjunction is going to be false. And then here, not Q is true, so they're not both false. So we have true. Now we can evaluate our ultimate statement, which is an and between here and here. So the final statement is if P then not Q and P or not Q, okay, and this is true only when both the statements that make up the and are true. So that would be true only if P then not Q is true, and if P or not Q are both true. Okay, so we look back at these two columns, and here they're not both true. Here they are both true. So if they're not both true, then the statement isn't true, it's false. Here they are both true, that makes it true. Here, they're not both true. But here again, they're both true. So that's one way you could document a truth table. I want to see that you've got the thing. First, it's not even a correctly documented truth table if you don't set it up in such a way that every column can be evaluated by looking at just two columns that precede it. As in, this can be evaluated by looking just at the P in the not Q column. This one could be evaluated, again, by just looking at the P in the not Q column. And then this one, this and statement, is evaluated by looking at these two columns. Down here, we reiterate the rule so that if you happen to screw up, and it's inevitable that, if you do enough of these, you're going to miss something. If you just accidentally put a false here but have the right rule, then I'm not going to penalize it particularly heavily. If you put a false here and don't have the rule down here, then I'm going to assume you don't know that rule, and there's going to be a much heavier penalty. Although if that's the only mistake you make on the whole thing, you probably still get, more than half credit on the problem. But if you make a bunch of those mistakes, it's going to be much better for you if you got the rules down here right and just write them down carelessly, write down some of your values carelessly, than if you don't document anything. So two good reasons for documentation. One is that's how you do mathematics, that's how you reason, that's how you communicate. And two, you end up with more points on the test, which is probably your higher priority right now. And I don't blame you for that, that's fine. Okay, there it is. Okay, that's all I had noted that I wanted to go over. And I've used up both of my boards. I could wash them, but it's about 41 degrees in this room. And I'm comfortable, but because I'm moving around and stuff, it's pretty heavy. And I wasn't comfortable, I'd have another layer on, wouldn't I? But that's pretty much, actually I do have another small board like this, but I don't really have anything more that I want to add at this point. And this video is getting long enough. So hopefully this will give you the flavor of the things that you need to do. And I do advocate that you watch this video before you do a whole lot of the problems if you have time. Of course, I'm telling you this at the end. This is probably not going to do you a lot of good if you've watched the whole thing and said, why did I watch this whole thing? Anyhow, there it is. And I wish you luck. I'll be looking forward to seeing more of your work, and sooner rather than later, I hope, so that we can get you decent feedback in the time that I have. And I see that in the process of making this, I've got 3 new emails. I would expect that before too long, I'm going to start getting a dozen or more emails per hour. I'll get through those as quickly as I can and get your feedback as quickly as I can. The 3 that I see there, probably going to get their feedback pretty soon. Okay, well, good luck. Hope everybody does well on the test. I'll give you more feedback. I'm inspired to make more videos and have time. You might see more. Okay, well, good luck. Hope this does you some good.